The Unix operating system is renowned for its elegant and powerful approach to handling input and output. One of the cornerstones of this elegance is the concept of I/O redirection. This mechanism allows users to control the flow of data between processes and files, significantly enhancing the flexibility and efficiency of shell scripting and command line operations. At its core, I/O redirection empowers users to change the default sources and destinations of input and output streams. By default, commands in Unix take input from the keyboard, standard input, and send output to the terminal screen, standard output. However, with redirection, we can direct these streams to read from or write to files, effectively automating tasks and creating complex data pipelines. The true power of I/O redirection lies in its ability to seamlessly connect different commands, forming powerful sequences. This is achieved through pipes, represented by the pipe symbol, which channel the output of one command as the input for another. This chaining of commands, facilitated by pipes and redirection, forms the backbone of Unix's philosophy of modularity and composability. In essence, I/O redirection and pipes are fundamental tools that elevate the Unix shell from a simple command interpreter to a versatile scripting environment. By mastering these concepts, users can harness the true potential of the Unix operating system. Before delving into the intricacies of redirection, it's crucial to grasp the concept of standard streams in Unix. These streams represent the default channels through which programs interact with the system. There are three primary standard streams: standard input, standard output, and standard error. Standard input, often abbreviated as std_in, represents the default source of input for a program. Typically, when you run a command in the terminal, it expects input from the keyboard, which is treated as std_in. For instance, when using a text editor like Nano, the text you type is sent to the editor through std_in. Standard output, denoted as stdout, is the default destination for a program's output. In most cases, stdout is directed to the terminal screen, displaying the results of a command. When you execute a command like ls to list files, the list of files is printed to the terminal, utilizing stdout. The third stream, standard error or stder, is specifically designated for error messages and diagnostic information. By separating error messages from regular output, Unix ensures that even if stdout is redirected, errors are still visible to the user on the terminal. This separation is vital for debugging and monitoring program execution. Understanding these standard streams is essential because I/O redirection primarily involves manipulating these streams, directing them to different sources or destinations. Output redirection forms the foundation of manipulating data flow in Unix. The greater than and double greater than operators are fundamental to this concept, allowing us to redirect the standard output of a command to a file. The greater than operator, known as the output redirection operator, redirects the stout of a command to a specified file, overwriting the file's contents if it already exists. For instance, the command ls greater than file_list.txt would redirect the output of the lsor command, the list of files, into the file_list.txt, replacing any existing content in file_list.txt. In contrast, the double greater than operator, known as the append redirection operator, appends the stdout of a command to the end of a specified file. If the file doesn't exist, it is created. This operator is particularly useful when you want to add data to an existing file without overwriting its contents. For example, date double greater than log.txt would add the current date and time to the end of the log.txt file. These two operators provide a straightforward way to capture the output of commands, storing them in files for later analysis or use as input for other programs. This capability forms the basis for automating tasks and creating more complex shell scripts. While redirecting standard output is essential, Unix provides further control by allowing the redirection of standard error. This is particularly useful when you want to separate error messages from regular output or log them to a specific file. The two greater than operator is used for redirecting stder, Similar to stdout redirection, 2 greater than overwrites the target file, while 2 double greater than appends to it. For instance, command 2 greater than errors.log would redirect any errors produced by command to the errors.log file. In situations where you want to capture both stdout and stdir in a single file, you can use the ampersand greater than operator, known as the combined redirection operator. The command ampersand greater than output.log would redirect both the standard output and standard errors of command to the output.log file. Understanding error redirection and combined redirection provides finer control over how your scripts and commands handle output, enabling better debugging, logging, and overall script management. Section 5. Practical examples, grep WC, and sorting. To illustrate the practical applications of I/O redirection, let's examine some examples using common Unix utilities like grep, WC, and sorting commands. Grep is a powerful tool for searching for patterns in text files. Combined with redirection, it becomes even more versatile. For instance, to find all lines containing the word error in a log file named system.log and save the results to a file called errors.text, you would use the command grep errorsystem.log errors.txt. The IWC command, short for word count, is often used for counting lines, words, and characters in files. When combined with redirection, you can easily count specific elements within a file. For example, wcl file.txt would count the number of lines in file.txt by redirecting the file's content to wce as input. Sorting commands like sort and unique can also benefit from redirection. For instance, to sort a file named data.txt and remove duplicate lines, you can use sort data.txt unique sorted _unique.tsext. This command chain first sorts data.text then pipes the sorted output to unique to remove duplicates, and finally redirects the result to sorted _unique.tsext. These are just a few examples of how I/O redirection enhances the capabilities of standard Unix commands, making them more powerful and flexible for various tasks. Section 6. Advanced Technique Process Substitution. Process substitution is an advanced technique that further expands the capabilities of I/O redirection in Unix. It allows you to treat the output of a command as if it were a file, effectively using commands as input for other commands. The syntax for process substitution is command. This notation creates a temporary unnamed file descriptor that represents the output of the enclosed command. This file descriptor can then be used as input for another command, just like a regular file. A common use case for process substitution is comparing the output of 2 commands. For instance, to compare the files in 2 directories, you could use diff lsdir1, lsdir2. This command uses process substitution to treat the output of lsdir1 and lsdir2 as files, which are then compared using the diff command. Process substitution is a powerful tool for creating complex command pipelines and manipulating data streams in intricate ways. By treating command outputs as files, you can leverage the full range of Unix utilities for processing and analyzing data. Section 7. Named pipes inter-process communication. Named pipes, also known as FIFOs, first in, first out, are a special type of file in Unix that facilitate inter-process communication, IPC. Unlike regular files, which store data persistently on disk, named pipes act as conduits for data flow between processes. The mkfifo command is used to create a named pipe. For example, mkfifo mypipe creates a named pipe called mypipe. Once created, any process can write to or read from the pipe, much like a regular file. The key difference lies in the fact that data written to a named pipe is not stored but rather buffered until another process reads it. This makes named pipes suitable for real-time data exchange between processes. For instance, one process can write data to mypipe using command mypipe, while another process simultaneously reads from it using command mypipe. This allows for synchronized communication and data transfer between independent processes. Name pipes are a powerful mechanism for building more complex applications and scripts in Unix, enabling the creation of sophisticated data pipelines and communication channels between different parts of a system. Section 8. Conclusion. In conclusion, I/O redirection and pipes are fundamental concepts in Unix that empower users to control data flow, automate tasks, and build complex scripts. By understanding and utilizing these mechanisms, you can harness the true power and flexibility of the Unix shell, from basic output redirection with YARG and to advanced techniques like process substitution and named pipes. Unix provides a comprehensive toolkit for manipulating data streams. Mastering these concepts will undoubtedly enhance your productivity and open up a world of possibilities in the Unix environment.